Hello everyone, welcome to the class. Today let's talk about the ASCII code. What's the ASCII code? How our computers read your files, read something you wrote. So it's all about ASCII code. Let's check it out. So in a computer world, there's no character. So in our real world, there's English character, there's like other languages character, for example, Chinese, Japanese, Korean, there's so many different characters. But in computer world, there's no character. So how our data is represented in our computer? Actually, 0, 1, 0, 1, 0, 1, only 0 and 1. So if you remember in Matrix, this old movie, the I think the main character Neo at the end when he tried to see everything in the world in the computer world like because there's a real world and computer world controlled by robot, right? So when this main character like try to see everything in the computer world, he can only see 0 and 1. Why? Because inside the computer world, there's only 0 and 1. There's no other character than 0 and 1. There's no even there's no even number 2, just 0 and 1. So if the data is only 0 and 1 in the computer world, how we can represent like a whole bunch of different stuff, for example, your pictures, for your languages, how we represent. So this is a very interesting topic, right? So actually, inside the computer world, they have a 0 and 1. Use 0 and 1, try to use couple of 0 and 1 to represent a number. For example, if we try to present a number 6, here, we can use 0, 0, 0, 0, 1, 1, 0 to represent 6. Actually, it's called binary. So we use binary to represent a decimal, to represent other stuff. So if we want to present a number like a 255, this number, we can just use 1, 1, 1, 1, 1. And inside your system, your memory, the basic unit of your data storage is 8 bits, and we call it 1 byte. Okay, so we use bytes to store the data, and every byte has 8 bits, which means we can store a number like 255. So we can store a number 0 to 255 for each byte of data. Of course, we can combine multiple bytes together to represent a bigger number. But basically, the basic unit for your memory, for your systems, is 1 byte. So even you try to represent a very small number like 6, you still use 8 bits to represent the 6, okay? So it's very like kind of basic unit. So because we have this basic unit, we can also use this basic unit to represent a character, okay? So each number represent one character. For example, this is something we have, the hello world. So inside our hello world, we try to say, okay, include blah, 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 include space and stdio h. We try to say something like this. In your computer, even though we try to type everything like this, but it does not store in a computer in this way. Okay, so the way we can see it, because there's a software, there's some like operating systems, there's some magic stuff. They try to inside a computer, they try to change the number to a character in your screen, your output. So you remember the output? So they try to do something for your output, so you can see it. But inside the computer world, the file is represented like this: 35, 105, 110, 99, 108, 117, 100, and blah, 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 blah. Actually, this is the number. So inside the computer world, it looks like, of course, 31, 35 is a bit. So 8 bits. 8 bits represent 35. 8 bits represent 105. 8 bits 110. So every something here is 1 byte, 8 bits. Okay, so it's used this number to represent what you actually wrote. So the computer, when your machine try to reduce your file, it still read a whole bunch of 0 and 1. So for example, 35, I don't remember what the binary is. If we see, for example, 6, it will be 0000110. So it will see a whole bunch of like 0 and 1, 8 bits to represent one character. Then the second 8 bit represent another one. Then it's use it even for space. You can see even for space, it has a 32, this number. Actually, you can see the details in this ASCII table. This ASCII table shows every character, what's the number represent the character. For example, if we use 0, it's represent null. Null means like a very like nothing. Okay, so if we use something else, for example, backspace. So let's backspace is should be 000 0 1 0 0 0 8, the number 8 in decimal. Okay, so of course there's a space, there's a capital A, there's a lowercase a, there's even a number. Very interesting, right? So actually in C word, in C languages, you can do something like, okay, I have a character equal character X equal to, for example, A, no, equal to 0. Then I can say X minus 48. Try to use integer Y equal X minus 48. Then this Y will become 0. Interesting, right? If we change the character, this character to let's say 9, then y equal x minus 48 will give us 9 here. Why? Because x right now in ASCII code 9 is what number here? So it's actually 57. 57 minus 48 equal to 9. So you can get the real numbers. So this is how you like convert the character to integer in C. So actually all about this is based on the ASCII table. ASCII table shows a lot of information. Try to check it out. Try to see, okay, if I want to spell my name, Joe, how I spell it. We can take a look of, okay, J is 74, O is lowercase, is 111, and E is 101. And this is Joe in your computer. So if you can read this number and convert it back to the character, then you probably can do everything you probably can read it at like a computer. But I personally cannot do it, and I don't suggest you to try to remember this table. You don't need to remember this table. Okay. So when you need it, try to take a look of these tables. Okay. I hope you enjoyed today's lecture. Today's lecture, we talk about ASCII table, how your data represent in your computer, how your CPU, how your machine actually read this data. Actually, it's all about the number. What's the number? Binary number, 0 and 1. But 0 and 1 is never 9 now. So there's a basic unit we call bytes. 1 byte equal 8 bits. Use 8 bits to represent different numbers, then convert each number to a characters. English. In other languages, it might use different, like more than 1 byte to represent character. For example, in Chinese, they use 2 bytes to represent 1 character. I believe in other languages, they have some like a special like a way to do it. But anyway, you got the idea. So you use the number to represent something. So this is how your computer works, how your computer actually work in their world. Okay, so hope you enjoyed today's class. See you next time. ASCII table is interesting.